In this example, we want to take a vector, -2, 1, with respect to a given basis, convert it into a standard basis, rotate it 90 degrees counterclockwise in that basis, and move it back to the original basis. So the transformation matrix that we would use to take this from basis B to our standard basis E is given by the columns of the basis vectors. So -1, 0, 1, -1. In order to take something in E and rotate it 90 degrees counterclockwise, we end up with cosine 90, negative sine 90, sine 90, cosine 90, which just so happens to be 0, -1, 1, 0. In order then to take something that's in our standard basis E and move it to B, we need to take the reverse of the transformation matrix that takes things from B and moves them to E. And so this is given by 1 minus 0, so it's 1 times -1, 0, 1, -1. That's not true. That's a 0. This is a -1. Flip those two, make these two negative. Okay, so if we start with the vector -2, 1, and we first need to move that from B to E, we multiply by -1, 1, 0, -1. So this creates me a vector in E. I can then rotate that by multiplying by -1, -1, 0, -1. So this is in E and rotated. And then if I want to take that vector that's in E and rotated and move it back to basis E, I multiply by -1, -1, 0, -1. So this is back in B after the rotation. And so multiplying all those matrices together, I would end up with 1, -1, -1, 0 times -2, 1, or that's -2 minus another 1. That's -3, and then +2. And so that's the vector I get after I move it into my standard basis, rotate it in the standard basis, and move it back to my given basis B.